This call is now being recorded.
Okay. Chalo, thank you, Himanshu. So, are we able to see the slide?
Yes, sir.
Yes, sir. So just we'll have a recap what we have done in a session 1. So we talked about why Six Sigma methodology, why organizations are adopting methodology for improvement, a particular Six Sigma methodology. Then we also discuss about the different approaches used for identification of the projects like vision, mission, objective, etc. And then another approach which is called as an BPM approach, is business process management approach, which is followed by G. And we actually looked at how Six Sigma methodology works. Again, we talked about for an perfect solution, a preventive solution to avoid the reoccurrence of the problem rather than a root cause to root out the problem. Means it should not reoccur. That is what is a concept which is emphasized in Six Sigma. And we talked about the system or a process change. So something which improves by monitoring by a manager is not a Six Sigma project. So we need to do something on a system or a process, or we need to do some changes in standard operating conditions, standard operating procedures, or something which is a permanent gain. And the idea is that it should come, the result should, why should improve without monitoring, so that we control excess, and we control excess in a such a way that why will automatically come. That is what is the theory behind a Six Sigma work. So then we also looked at there are various phases for a Six Sigma: define, measure, analyze, improve, and control. So what exactly is done in define phase? That we looked at what are the concepts of a define phase. That is, who are the customers? Is my customer internal? Looks for an effectiveness or efficiency in the process. And then what is my metric for improvement? How do I arrive at a metric from my customer voice, or rather voice of a customer? And then once we know what is my CTQ, critical to quality, what I need to improve, then I write down a project charter for the same. So basically, writing down a project charter is a very important state of any project. Whether you call it as a Six Sigma project or any improvement methodology, so the charter of the project is most important. You take any assignment, the charter is most important, where you write down all the boundaries and metric of the improvement. So it is very important, which is emphasized in Six Sigma, is that every improvement should be converted into numbers. So something which is in English doesn't have a sense in Six Sigma. So we have to convert everything into numbers, and those numbers should improve. And if those numbers are statistically improved, we say that the process has changed. So this is what we write down in a charter. So we write down everything. What is the unit? There are six elements of the charter. Why I am doing this project? Then what is the unit of measurement? Is my work really reflecting in that unit of measurement? Then what will be the benefit? That is link what we write in the business case. In English, we have to turn them into a numbers in what is the benefit from the project. Then we clearly write down the scope of the project, where it starts, where it ends, what boundaries, means thinking boundaries we are going to consider and not considered. Then we also talked about a very important phase, which is important aspect, which is a secondary CTQ, or which is called as a constraint CTQ. The constraint CTQ is the way I am not going to improve it. So that is most important, because many times what happens in organizations, we improve something, but the other thing gets spoiled. So what are those things which are likely to get spoiled must be written down and monitored for at least remaining steady. That is what is most important part of a charter. And then we have also written down the timelines, phase-wise timelines, which is called generally project completion timeline, etc. So with this background, now we move to the next. Can you go to the next slide, please, Himanshu? So what we will be doing today is probably the next phase of a charter, that is process mapping. And then we will also look at the major phase. Why major phase? What are the concepts of the major phase, and what are the tools which are used in major phase? It is basically about the measurement system analysis. So is my measurement system right? And then we'll move to an analyze phase, where we will try to find out with the various tools what are the excess, or how to narrow down on the excess using the statistical tools or 7QC tools. Move to the next slide, please, Himanshu. So we start with the process mapping. Process mapping is a very simple phase. So how does my process look like now? So if you recall 3 questions, the third question which was asked in my defined phase, how does the process look like? That is, what is as-is process. So what can be the objectives for a process mapping? What is my actual process or say documented process? So you are not much acquainted with the industry culture, but many of the times in the organization, there are documented processes which are in the cabins, and the actual what is being done is different than what is documented. So are we really doing what has been documented? So there is always a tendency to have a shortcut, their own views to operate a process, etc. So what is actual versus a documented process? Then there is another concept which is also very important, is a value-added work or a non-value-added work. So we'll look at that, what is non-value-added work and value-added work in detail when we look at the lean tools next time. And what are the inputs to the process and what are the outputs from the process? That also will map. So basically, if you want to improve any process, there is something wrong with that process. There is a one way you can improve the process, and the another thing is, what are your process is fantastic, but there are inputs which are coming bad and spoiling the output of the process. So it can also happen. So we are trying to track both what is actual process is, what are the actual activities in the process, and what are the inputs which are coming to the process. So when we talk about the process map, process map is at 3 levels. It is called as a macro map, process flow diagram, and detail map, input output worksheet. So next slide, please. So when I say a micro map, it is a business overview, or we can say the helicopter view of any plant, operating plant, etc. Okay, so generally it is done using a SciPoc. So it is a high level overview from an top 2,000, 20,000 feet, etc. etc. is a bigger picture. Then the next step is at the rooftop. So you are landing on the ground, and what are the different practical links which are operationally being done at site. And the third level, which is called as an process step. So you go to each and every process step to identify what is the input which is coming to this process and what is the outcome from that process step. So what is helicopter view is an overall process. So if you look at, I am having a polypropylene plant. So, mota, what will be inputs for poly making and polypropylene, and what will be the outcomes for an propylene? You list down everything. Even if you are producing a waste, you write down that waste also, and what are the inputs and what are the agencies which are supplying you that input. Then probably at the next step, it is a process flow diagram, PDF diagram, where how exactly the material is moving, so that going forward to the third step, you can map what are the inputs to the reactor, and then what are the inputs to the next process, etc., and what is the final output at all steps. So let us look at next slide, please, Himanshu. So let us start. If you go, as it is obvious, if you are at the top, you will have some information, but as you come on ground and go to an actual process, the details of the process will increase. The insights to the process will increase. Next. So this is what is generally done. It is called as a SIPOC model. So what is SIPOC? You have a process at the center. What are the inputs and who are the suppliers for the process, and what are the outcomes and who are the customers for that process. So the terminology used in Six Sigma is SIPOC. So supplier, input, process, output, and customer. So you map every process. You can map any process and you can identify inputs for that process, who is the supplier for that process, etc., etc. So I have also written as an copies. So it is simply the theory of G says that actually the physical movement of a material comes from a supplier to a customer, but the mental thinking goes from a customer to a supplier. So they call it also copies. Actually, if you look at generally what happens, the traditional operational process or transactional process work in a SIPOC model, while business processes which they run in a copies process. So to give you an example, if you suppose you want to you are an entrepreneur and you want to have a refinery in India. So if you want to have a refinery or any plant like chemical producing plant, what do you look for first? So let us take an example of a refinery. So if you want to set up a refinery in India, what do you look for? You will look for are there customers? So the customer first. So if there are customers, how much quantity they will take? So how much tons, metric tons they will take from us, etc., etc. So depending on output, based on you will decide the process. And based on that process, you will decide what are the inputs which are required and who will be the suppliers, etc. So if you look at the business process, it goes in a copies model. While the transactional process, physically the process goes in from a SIPOC model. So that is what both the phases are important. The business process is also important. So it is done in a copies model. So next slide, please. So the next step is a process flow diagram. So process flow diagram is what is concept of a process, what is the ideal process, and what is the reality at shop floor. And we want to bring that from reality to an ideal process, and we need to identify gaps and make the process fast and suitable. That is what is an approach which what we'll understand using a process flow diagram. Now process flow diagram or Swimlane Map, etc., makes more relevance when you are talking about transactional processes. Now, if you are dealing with the chemical processes, that is elimination of steps generally do not happen. So what we look at is the next step. What are the inputs for each and every step, and what are the outcomes of each and every step? So next slide, please. So this is the next slide. Next step, where we will identify what are the inputs which are coming to each and every step, and what are the outcomes of each and every step, or rather that we talked about identifying the potential excess. So this is very important process step to track all the inputs coming to the process and identify those as a potential excess which may affect the output of the process. So this, as far as a chemical process or any process industry is concerned, this step is very important. Okay, because you really can't change anything in a process flow. So whatever, if I am talking about a polypropylene PP preparation process, my process flow will not change. But what is important for us is to understand what are the inputs for the various inputs which are coming to the process, and are they satisfying the needs of the next process or not. So next slide, please, Himanshu. Let us understand it by an example. So let us look at an example which is a SAPOC. Here what we are trying to take up is a very simple example, which is a tea preparation process. So if you look at an helicopter eye view of a process, so what is the process? The tea preparation process. So what are the inputs to that process? So probably water, milk, sugar, gas, utensil, manpower, if I am running a tea stall, etc. So I am also talking in that aspect as in business or industry. So I am talking about the manpower is required for preparing a tea, serving a tea, etc., and which is supplied by owner or a contractor. So I have also identified the suppliers for all these inputs, and what could be the outputs of this is a cup of tea or a waste, and who are the customers for the same. Okay, what is this? This is an helicopter top view. So I am trying to understand abroad what are the inputs and what are the outputs of the process. Next slide, please. So the next is an actual process diagram. So how exactly, step by step, the tea making process goes on. Okay, so you can have a start, take utensil, pour major quantity of water, put on the gas like that, then add sugar. Then whether you want ginger masala, yes, no, boil the mixture, add tea powder, keep it for boiling, then filter the mixture, and you will get a tea. Now this is what is a process flow diagram. Now taking this ahead, what we will be doing, we will be identifying all the inputs which will have effect on my output. So next slide, please. So we have already said what are the inputs to the process. So I am talking about the input output worksheet. IO means input output worksheet. So what I will be doing, I will be identifying raw materials, information, equipment, which can have an impact on my t-test. So what is Y here? The Y here is an t-test. So is it satisfactory, not satisfactory, good, not, etc. Okay. So going forward, so let us understand what are the raw materials which are required for my tea process. So I need an water, I need an milk. So exactly what is, how much is the quantity of water? What are the specifications of that water? Are they important? If there is something goes wrong with the water, will that impact my tea taste? If yes, I am calling it as an potential X to go ahead in an analyze phase. So that is how the process map help us. The process map help us to identify various potential excess at all the process steps. Are by step by step or by input wise. So here what we are talking about a raw material. So raw material is water, milk, sugar, and tea. And we are talking about the specifications of those raw materials. So milk, quantity of milk, different types of milk. If we are using a cow milk, buffalo milk, is it going to affect my tea taste? If it is going to affect my tea taste, then I am calling it as a potential X. So when you are mapping a process, you are not deciding that this will make impact or this is not making impact. You are trying to identify only the potential X. The next phase, which is an analyze phase or a statistical tools, will help you to screen down those potential X and narrow down on a vital excess. So go ahead, Himanshu, next slide, please. So this is about the raw materials. The next part is about the equipments. So what are the equipments which are used in tea preparation? It can be a different type of a utensil. Somebody is taking aluminum utensil, somebody is taking copper utensil or a stainless steel utensil. The important point here is, if it is making you feel that it is making a tea change in taste for a tea, or it is going to spoil my tea, you are calling it as a potential X. If you don't feel, but generally you don't discard any X, the discarding of the X will be done in an analyze phase, and with you by proper tools, not by a judgmental solution or mujhe aisa lagta hai or subjective thinking like that. So we can use also various heating devices like a gas burner, electric kettle, kerosene stove, or chula. Every heating device will have a different taste. So it is important to understand whether it makes a difference on the tea taste or not. If you are using a filter, what is the filter size? What is the life of a filter will also impact your tea taste. So next slide, please. So this was about the equipment. The next important phase in tea making process is then what is standard operating procedure. So when to do an addition of a sugar, how much time to boil, when to add milk. Few people add a milk when they start at the start of the tea preparation. Few people have a process where they add milk at the end. So where to add sugar? Few people add sugar at the beginning, few people add sugar at the end. So what is important here is these are the different SOPs followed by different families or people. So are they making difference on my tea taste? If they are making a difference on my tea taste, I am capturing it as a potential X and taking it for the further analysis. So traditionally, when we are mapping a transactional process, it is generally done in a Swimlane map. So Swimlane map is in front of you. So there are various organizations, various departments in the organizations which are involved in the process. So if you look at the slide in front of, it is about an procurement process. So somebody user raise an indent for a material, then it goes to purchase, then again manufacturer, then store, then inspection, and then again it comes to a user. So this is what is an this is a simple process which cuts across the many departments of the organization. And what is important, why it is called as a swim lane? Because if you look at a swimming competition, the participating swimmer swims in his own lane. So like that, the whoever department is working in his own lane and does the job when it comes to him. That is why the process is called as this particular mapping is called as an swim lane map. So this is generally done to understand the complexity in the processes. So just look at, for an example, organizing a meeting has 25 steps. And this is just a process flow chart. But if you put that in a swimlane structure, you are probably also clear about whose responsibility is what. So you are identifying the functional responsibilities of a department in that swim lane. So it is better for review also and understanding also what every department has to do when it comes to his place, etc. So this is a simple process flow diagram of organizing a department. Okay, so for any process you can draw a process flow diagram. So this is what is a process flow or process mapping. This is very important to understand as an as-is process. When you are going for improvement, it is very important to understand what is as-is process, and rather than I gave you an example about an parameters. So it is not a subjective knowledge or somebody feels that temperature badhana chahiye or pH nahi karna chahiye. So what we are trying to find out, we are trying to capture all the excess which we feel can have an effect on my Y. And we then, not on a subjective knowledge, but using a statistical tool, we will eliminate those excess. That is what is in Six Sigma processes. So the process mapping is one of the important steps in identifying the potential excess. and then you then you move ahead for an analyze phase. That is very important. So before going to an analyze phase, once you identify potential excess, it is also important to measure the data. What is my as is process capability is. Go to the next slide, please, which is called as an major phase. So what we are going to measure, do in a major phase, again, I told you that we will be answering 3 questions. So the fourth question is define performance standards. So what is the best way to measure? That we need to understand, because many of the times there are different people who are taking measurements and have an different processes or different thinking about the measurement process, and then which is the right process. So we need to standardize how to take a reading and how to do a titration, and is that reading is matching with the one another, etc. So I will explain you in detail what I mean by a measurement. Then establish next, not next, stay back. Establish a data collection plan. If suppose you do not have an data for all the other parameters, then you can establish or plan a data collection plan. And basically a measurement system analysis means what I am taking for an improvement, can I trust that output data? And is my measurement system variation within limit? And once I establish that my measurement system variation is within limit, then I go ahead to establish what is my process capabilities, that is how good I am today. So let us move to the first step. Next slide, please. So what are the deliverables of the measure phase? Develop a data collection plan. If suppose you are not measuring any data, suppose you are talking about a cycle time reduction. So it may happen that the process, the transactional process has several steps, and you are not capturing that data from a system. So you will have, because as you have to reduce the cycle time, you will like to understand how much is the time taken at each step. So we took an example of an organizing a meeting. So organizing a meeting probably, or completing the meeting has 25 steps, and organizing a meeting is always delayed. So you would like to understand where is the delay. For that, at each step you will have a time stamping and collect the data, how much time was required for that particular step, etc. That is what I mean as a data collection plan. Then detailed process map, then input output worksheet, validate the measurement system, that is most important in measurement system analysis, and determine the process capability and the sigma level. So let us move to the next. So what is the best way to measure? I think I don't have to say anything on this slide. You are well, the slides explain everything, that I need to understand where I need to measure, and that has to be standardized, and everybody is taking the reading at the same level and same style. That is what is emphasized in a measure phase. Next slide, please. Also, when I say define performance standard, so let us say I am talking about the yield. So how I am calculating yield has to be clearly written down. So for example, in any petrochemical industry, there are 2 ways to calculate yield. Even this is happening in our organization also, whether input or output matching. We can calculate yield, how much is the input and how much is the output. Output input ratio will give you the how much is the yield. There's another way of calculating yield is production divided by production plus waste. So how you are calculating yield has to be, you must, because this is your CTQ. So how you are calculating yield has to be clearly written down in your performance standard, that I am calculating yield like this. It is to give you a very simple example. How will you define a lunch time? Now somebody will say, I leave my desk from the office and come back to the desk after lunch. That is my lunch time. Somebody will say, I will enter the canteen and come out of the canteen. That is my lunch time. Now, if you look at that, both the definitions are right. But what you are considering as a lunch time in your project has to be clearly written down here. That is what I mean as a defined performance standard. Means your y जो आपका आ रहा है उसका इक्वेशन क्या है. So ये जो y yield percentage आप लिख रहे हो, that is input divided by output है या production divided by production plus waste है, has to be written down clearly. And then you have to also have an trust on that what way I am calculating is correct way of measuring the same. Then the next is my data discrete or continuous? There are two types of data, which is called discrete data and continuous data. What is mean by discrete data? Discrete data is generally a countable data. That is 1, 2, 3. How many people out of present 58 people are wearing a red shirt today? Is a discrete data. It cannot be 3.2. That is what is discrete data. And continuous data, how many percentage of people are wearing a red shirt? So it can be a fraction also, 15.3, 13.2, etc. So probably discrete data does not give you more information, but the continuous data gives you more information. Means it is also related to total number of, suppose I say there are 10 people wearing a red shirt, and there are 10% people wearing a red shirt, has a different meaning. So when I say 10% people, that means 10 out of 100 people are wearing a red shirt. It may happen in an earlier case when you are talking about the discrete data, 10 out of 20 are wearing a red shirt. So when you go to a continuous data, it makes or it gives you more information. So it is better to move on to a continuous data in your project. Generally try to avoid a discrete data and move to a continuous data so that it becomes more informative and more relevant for your project. Then the next step is data collected from a system or manually? Who is wearing a red shirt is being looked at automatically by some sensor, etc., or being manually. So if there is a fade red shirt or a pink shirt, so somebody will say it is pink or somebody will say it is red. So is that subjectivity is coming into picture when you are collecting the data? And if it is subjective or related to a human intervention or human decision, then you have to establish that all your inspectors are on the same platform and having a same standard to call it as a red and call it as a non-red. That is what is the data collected from a system or manually. And what is exactly the defect definition is. So it is important to understand, because everything, your capability of the process goes on with the defect definition in place. So what is you are going to call it as a defect? So it depends on what is your target. So basically, if you are not meeting a target, then it is called as a defect. And the whole Six Sigma methodology is based on this defect. So how many defects per million opportunities that you count, and based on that, sigma level is decided. So basically what we do in measurement system means we try to take up your all processes on one scale of 0 to 6 when we actually calculate the capability of the process. Next slide, Himanshu. So you'll understand that. So why measurement system analysis is required? So when we talk about any variation, we talk about the observed variation in the process. Now, next slide. Next. Now, it is very important to understand how much is an actual process variation, again the observed variation. One more time, enter. Okay, so actual process variation is equal to observed variation minus measurement system variation. Now, you are measuring something and that measurement system is not capable of identifying a change, then it may happen that your measurement system is not right and you are working unnecessarily on the process. And even if you improve your process, it is not going to improve because there is a measurement system variation. So, what you observe is a total variation in the process. Out of that total variation, there is few portion which is actual variation on the process, and there is a few portion, few percentage which is a measurement system variation. Now that measurement system variation has to be within limit, and if that measurement system variation is within limit, you can go for an actual process variation. That is what the process whole means. Now go to the next slide. Himanshu? Okay. So there is a total process variation. मैं आपको थोड़ा एग्जांपल देके समझाता हूँ ये. Let us understand. So what you are trying to do? You are trying to measure your hemoglobin percentage or any sugar in your blood. So you generally go to a pathologist and he will take out a sample. Now there are, if suppose his measurement variations, system variation is high, then it may happen that your sugar is actually not high, but you will be treated unnecessarily by a doctor. That is what we are trying to ensure here. So it is very important to understand that you give that sample 2, 3, 4. Generally, if doctor gets a doubt, he tries to, or he will try to tell you that repeat the sample, go to different pathology. We feel that uska kuch setting hoga, or etc., etc. But he tries to understand that whether that measurement system variation is within limit. So out of a total process variation, there is actual variation, which actual variation is in two terms, which is short-term variation and long-term variation, and the measurement system variation is because of an accuracy or precision. So discrete data, if you talk about a discrete data, it generally talks about accuracy, and if it is a continuous data, generally it is about the precision. I will explain you how it works with an example also. So what is accuracy and precision? So accuracy has got again three elements, that is bias, stability and linearity, and precision has got two elements, what is repeatability and reproducibility. So next slide, Himanshu. So what is accuracy and precision? Take a simple example of an cricket. So probably Saurabh Ganguly, who is fielding on deep fine leg and has to throw a ball on a wicket. So if he throws a ball 4 times, that is how you can spot the ball on your screen. So in this case, what we say, next slide. The Saurabh Ganguly is neither precise nor accurate. So next slide. So if you consider probably the Yuvraj Singh, who is also fielding at the boundary line and throws a ball. Next slide. So probably about the Yuvraj, you will say he is precise but not accurate. Means there is a consistency in his throws but not on the target. And next slide, please. If you take an example of a Jonty Rhodes, who is an excellent fielder, so probably you can talk about him that he is, next slide, he is accurate and precise. So what is accuracy means? Being consistent on target. That is what is mean by accuracy. And what is precision means? He is consistent but may not be on the target. So like you see, Yuvraj throws his ball which is consistent but not on the target. While if you look at the jaunty roads throws, it is consistent as well as on target. So that is what I mean by an accuracy and precision. So next slide, please. And then there are in a precision which are called as an repeatability and reproducibility. So like I said, if you give a blood sample for a measurement of a sugar, the same person, same thing is being measured, same character, same setup, same environmental condition, he gives you another reading. Now, if suppose he says the first sample, the first time when I did my analysis was 120, and the second time when I did my analysis was 122. So it cannot be perfect. It cannot be same. So there is a difference of 2. So one is 120 and 122. So what is the question here is that variation within limit? And if that variation is within limit, we call is a particular person is repeatable. So what is repeatability is the same person analyzing the same sample again. Is called as repeatability, and it has to match more than 90% every time. Okay, next slide, please. So next concept is on reproducibility. So what is happening? Same measurement system, same character, same setup, same environmental condition, but some different person is doing. Now, try to imagine if one person is doing and reporting that my sugar level is 120, and another person who is coming and reporting it as 130. So there is a difference of 10. Now, is that 10 the variation is within limit? If it is within limit, then I accept it. Yes, it is okay. But if it is not within limit, what I need to do, I need to go back to my measurement systems and set right my measurement system first, and then go for an actual improvement in the process. That is what is the concept. Okay, so it is very relevant about your blood sample. If you look at the situations in COVID today, it is of course a discrete data. Sometime the COVID used to be positive, sometime COVID used to be negative. So people say, "Arey, there is a gadbad in the sample, etc., etc." But it is the reproducibility and repeatability of an measurement system which is playing role to report that as a positive or negative or some numbers. So it is very important to understand how much is the variation, and if that variation is within limit, then I can go for an actual process variation and really address the actual process variation. That is what is the concept which is used in Six Sigma. And it is very important also because many of the time in the processes, there are measurement system variations and we go for an actual process analysis. So this is what is define and measure phase talks about why, and we are ensuring that how we are measuring why is really right. Suppose you are taking an example of an yield. Yield means you are taking it as an input or output. Okay, so input which is coming in form of a liquid something which you generally measure using a flow meter. So are those flow meters calibrated, etc.? Which are the questions you need to ask when you are going for an yield like of a project? Okay, and you must ensure that yes, what is being indicated that I have used 1000 kg or 1000 tons of raw material, which is authentic and has been validated by a flow meter, and the flow meter is regularly calibrated so that I ensure and I trust that whatever yield I am calculating is right. That is what is the idea. The next part of this is one is accuracy, other is precision, and the third part is next slide, please. Is which is called as a distinct category, but it is nothing but the resolution of the system, or you can call it as a least count of the process. So what is important? The slide shows you an 100-meter race, and in a 100-meter race, the photo finish is just by 100 seconds. So if you recall, in Los Angeles Olympics, PT Usha lost a medal for India by 100 seconds. Okay, so 100 millisecond. So what is the important point is how is the resolution? So resolution, now we are very much accustomed with what is the resolution of your camera in for cell phone. So what is resolution? You are well aware. So how much is the information, and the basic point is are we able to distinguish between two parts? So why it was declared that PT Usha is fourth? Only because the measurement system was capable to differentiate between third and fourth by 100 milliseconds. So what is the least count of the process? That is what is most important. And not, it is not depending, it is not like that every time you have to measure an 100 second. So it depends on what is the variation in the process. Now, why we need to measure 100 seconds in 100-meter race? Because there are two people, they are very close to each other. Now, if you look at a marathon race, is there making a point in counting 100 seconds for a marathon race? No. So what is important is what is the resolution of my process or least count of the process with respect to my process. Resolution of my measurement system or least count of my measurement system with respect to the process. So it is generally called as a rule of 10. So very importantly, we need to measure 100 millisecond for the 100 meters, but we may not read 100 millisecond for 800 meters, 1500 meters or a marathon race. So it is not about that every process or every project should have a high resolution. So what is important is that what process you are looking for and how much is that variation in the process, and with respect to that process, how much is the resolution of my measurement system, and is that measurement system is capable enough to detect the change in the process. Because what I am trying to do, I am trying to improve something. So if I am trying to improve something, will I be able to measure that change process? To give another example, you are working on reduction of weight. Now it has only a least count of 5. It is counting 80, 85, 90 or 75, etc. Now suppose I reduce my weight from 85 to, it may happen that it is not counted by your measurement system, while it will reflect only when I reduce down to 80. So can I go with that? And if I improve from 85 to 82, I will not be able to say that my process has improved. So if I want to do that at the end of the Six Sigma project, whether my measurement system will allow me and has a capability to measure that change in my process, that is what is most important and called as a number of distinct categories or the resolution of the process. Next slide, please. So once we establish all that, we have the numbers again to say that for an attribute data or discrete data, which is countable data, my repeatability, my reproducibility, and my accuracy has to be more than 90%. Now, if it is not more than 9, my variation is more than 10%, I go back to a process, check my process, set right my process, and then again go ahead in the project. That is what it simply means. So before going for an improvement, I really want to ensure that my measurement system variation is within limit. Now, if you look at an continuous data, it is called as an R and R, so repeatability and reproducibility percentage. So if that repeatability and reproducibility percentage is less than 10%, I call it as a green signal. If it is 10 to 30, it is orange signal, and if it is more than 30, you cannot proceed in the project. The first thing what you need to do is set right and measurement system. It is exactly like our signal process. So if it is green, then you can go. In a orange signal, sometimes you stop, sometimes you go. You take a call based on the situation there. So the call is taken by a champion or a process owner, because what happens, sometimes it becomes difficult or a financial burden to set right a measurement system process, and nothing comes out of that. So whether we have to set right that precise measurement process, and which may be a costly one, so that call has to be taken by a process owner and champion. But if your measurement system variation is more than 30, you need to set right that process first, however how much costly it is, and then go ahead in the process. This is about also a distinct category. Distinct category is nothing but what I explained on the earlier slide. It is a number of distinct categories, means what is a list count of the process. Is that capable to measure if I improve marginally, or my improvement is slightly, then whether I will be able to detect that using my measurement system. That is important for resolution of the system. So with this check on the measurement system, we go ahead in the project. So let us look at an example. Next slide, please. So this is an example of an attribute data. This is an actual example of an discrete data. Please understand, one bottle is being produced. I am giving a very simple example of bottle. So you look at a Coca-Cola bottle or etc. So a bottle is being produced, and whether this bottle is okay or not okay is examined by different operators. There are a number of operators in the process. So I have picked up 3 operators, and there are 14 such samples. Okay. So all 14 samples were examined by operator twice. Of course, he don't know the results of a try 1 when he is going for a try 2. So what has tabulated is his operator 1 has taken decision for one sample 1. This is pass. And then operator 2 does it again as in try 2. And what is his observation is, that is how it is written down. That is operator 1, try 1, try 2, operator 2, try 1, try 2, and operator 3, try 1, try 2. And again, it is also noted what is an expert opinion or accuracy is. So ideally, the try 1 and try 2 of an operator should match. So on your screen, try 1 and try 2 of an operator 1 is 100%. That means what is this? He is repeatable. Okay. So if you look at an operator 2, the try 1 and try 2 is not matching. It is matching only 78%. Means there is a problem with an operator 2 understanding. And if you look at an again operator 3, it is matching 100%. So it is repeatable. But if you look at the operator 1, 2, 3, 6-way matching, it is not matching. It is matching only 57%. That means they are not reproducible. So what is reproducibility? The opinion of operator 1, operator 2, and operator 3 should match. And any of the opinion is not matching, it is not reproducible. So there is one concept which is repeatable, which is what operator 1 is doing for the first time and a second time. If it is matching, we say it is repeatable. And if it is not matching with all the 3 operators, then I say probably that it is not reproducible. Same example, you can take often simple your blood sugar. So somebody has given a blood sugar and he says 120, 122. He says 132, 130. The third operator again says 115, 118. They are consistent with their result, but are they accurate? The accuracy here, when you are talking about the consistency, you don't have a correct answer for this. So that accuracy comes with the reproducibility among them. And like what we do in titrations of the chemistry. So what we generally do in a chemistry, when we do simple titration, our both readings should match. That is repeatable. Your reading should match with an expert. That is what is an reproducibility. And if that is within limit, you are given marks. Here we say the measurement system has passed. Okay, that is what is meaning by a measurement system analysis. And if it is not matching with an accuracy, or what is an ideal result is, then it is called the percentage is just 42%. Ideally it should be more than 90%, and this measurement system is not that capable. So that now, if suppose with this type of a measurement system and this type of an operators present in the system, I try to improve the quality of the process. Will that really improve the process? No, because there is a variation in my measurement system. So what I need to do, I need to set right my measurement system variation first, and then go for an actual improvement in the quality. Because even if I work or even I do some improvements in my process, that is not going to reflect, that may not reflect in my quality, because there is a measurement system variation. That is what is I mean as an variation in the process. So go to the next slide, please. So once I establish that my measurement system variation is within limit, I go for the answering the third question in measure phase. That is what is an capability of the process. So the capability of the process. Are you aware about the dabbawalas in Mumbai? So here are the picture. Next, go to the next slide. So what are the dabbawalas do in Mumbai? So you have seen that in a picture. Is an unique service industry in Mumbai. What they do, they collect freshly cooked food in lunch boxes from their residences, and they deliver it to the employees in main Bombay. They collect the tiffins from suburbans and actually deliver them to their offices in Mumbai. So delivering it to their respective workplaces and returning the empty box back to the correct customer residence, and by using various modes of transport. So probably they will collect the data, collect the dabba from home, and ride on the bicycle to come to a railway station. Then they will upload that dabba in railway. Probably depending on the station, that tiffin will change over the railway and then go to a particular office place. Now, what is the important in this is, what is the defect definition in this? Next slide, please, Himanshu. So what is the defect definition is? So what defect definition is based on the customer needs. So right person deliver on time each time. That is what is mean customer requirement is. If that is not done, we call it as a defect. And how many such defects or mistakes are done in the process, are occurring in the process, decides the how much is the sigma level. That is what Six Sigma methodology is. So based on the defects, now if you look at there are 2 lakh dabbas which are being delivered every day in Mumbai. So how many defects when they are delivering 2 lakh dabbas? Now scaling up to 1 million opportunity, that is 10 lakh dabbas. So probably how many defects during a week will decide what the sigma level is. What is the sigma level of the process is. Now what is the sigma levels? The higher the better. Now if you have lesser defects, your capability goes up. Now how this capability is calculated with? This capability is calculated based on what is the customer need is or the defect definition is. So it is very important to write down a definition, defect definition of an customer. And once that is established, one which is not meeting the customer requirement is called as a defect. Now, how many such defects are in your process or in your system, and you extrapolate that to 1 million opportunities or 10 lakh opportunities. So how many defects per million opportunities? And based on that, you calculate a sigma level. That is, next slide, please, Himanshu. Okay, so based on that, you calculate how many defects per million opportunities. As your defects goes down, your sigma level goes up and your yield goes up. This is what is an capability chart. So what we are trying to do, we convert everything on 0 to 6 scale. So whatever, somebody is doing a project on customer satisfaction, somebody is doing on a yield, somebody is improving or reducing the packing cost, etc., etc. Now, as a part, what we will do, we will bring all those processes on the scale of 0 to 6. Now, that is what is exactly was done by Jack Walsh. Jack Walsh was not a statistician, but he very well understood what is the sigma level of the process. So what he did, he tried to find out sigma level for all his businesses. G के जितने भी businesses थे, so what he did, he brought all those businesses on the scale of 0 to 6, and which is not performing, he started looking at that and improved the same. Now, what is important here is understanding a Six Sigma or a Sigma level is based on the customer requirement is. Means he have not gone by a number of money generated by a business or revenue generated by a business. He went by and what is his expectation from a business, and again that how my business is performing, and based on that performance he brought them on 0 to 6 scale, and he felt that it is not performing, then he had a look or he went deep into that to understand how he can improve the sigma level from 1.5 to 3, etc. So achieving a 6 sigma level at 6 level is very difficult, which is done by the Dabbawalas in Mumbai. Probably they have a defect level less than 3.4 in a week when they deliver 10 lakh of the dabbas. Now, to have this level of the capability of the process. Now, if you look at the background of the Dabbawalas, next slide, please. Just 99 is not enough. You have to be 99.999 to get an Six Sigma. If you look at the next slide, if you look at the background of the Dabbawalas, their education is just 5 to 7 standard. They speak only local language, that is Marathi. They don't even understand English. They can't read English. Then what is the secret of their success? So as I keep on saying you, the process is important. You have to set right process. The process is delivering. The people involved are uneducated, illiterate. They are not able to speak even English language, but they are delivering the output to the level of an 6 sigma level. So their percentage output as far as yield is concerned is 99.9999. So what is the secret here is the process. So Dabbawalon, in the case of the Dabbawalas also, their design of the process is most important, and the product is being delivered because of the process. That is how we call it as an product by process. So your product should come out as part of a process. So I gave you an example last time of an samosa wala or batata vada wala around you. He never does any quality check, but still at the end of the process, he delivers you a good quality of samosa. He doesn't check even, but it is a product by process. So he has synchronized the thing, everything is involved. Uh, what type of batatas are procured, how much they are boiled, what type of adrak is put, onion is put, how they are smashed, how they are mixed, what is the temperature of an oil, etc., etc. But it comes as a product by process, and he never checks quality by actually eating vada or samosa, but he is very sure that it is delivering a quality. So that is what is an example of an product by process, and all the emphasis of Six Sigma is product by process. So you need to focus on a process or a system so that the output will automatically come. That is what is an intent of an Six Sigma. So next slide, please. So it is why the particular process is called as an why the methodology is called as a rather Six Sigma methodology. So generally when we talk about how many standard deviations are being accommodated. So if you look at a mathematical equation of calculating a capability, so it is very simple. There is an upper specification limit to a process, and you have an average of a process. So how many standard deviations you are able to accommodate on one side of the process is a sigma level of the process. So if you talk it mathematically, it is USL minus LSL divided by standard deviation. So in a traditional process, which we look at as a statistical process control, we say that when my variation is plus minus 3 sigma, the process is normal. But in Six Sigma, what is emphasized is I should be able to accommodate 6 standard deviations on one side of the process. And that is what is a motive of an Six Sigma methodology, that we need to improve a process to such a level that we are able to accommodate 6 standard deviations on one side of the process. Now, that is why the process is called as an Six Sigma, or the methodology is called as an Six Sigma methodology. Now, what you have looked at earlier, Dabbawala example was a discrete type of a data where your number of defects are 1, 2, 3, 4, etc. These particular slides explain you the capability analysis using standard deviation and what is the difference between my upper specification limit and my average divided by standard deviation is how many standard deviations I am able to accommodate on one side of the process. So that is what is called as a capability of the process. Now you can look at your upper curve and lower curve. The lower curve is far better and it is far away from your upper specification, and there will not be the probability of the defect is very less. That is why the sigma level or the capability of the process is good. That is how you have to calculate the capability of the process. Next slide, please. Okay. So so anything which is in this case, anything which is beyond the specification, we call it as a defect. And when we calculate sigma level, we calculate based on the what is the probability of the defect. Now if you want to improve your sigma level, either you have to reduce the variation like you have seen in an earlier slide, or eliminate defects if it is a discrete data. So as your defects goes down, your sigma level goes up, and as you reduce the variation, your sigma level will improve. So that what we are trying to judge is what is the probability of the defect, and based on that the sigma level is calculated. Next slide, please. Okay, so as we reduce the variation, if you look at the process where my variation is high, my sigma level is 2. As we reduce the variation at yellow, my variation is less, my sigma level goes up to 6. Obviously, my defects also will be reduced from 3 lakh to 3 per million. Next slide. So what is important? is if you have a bigger car and you want to park it in your garage, uh, if your car is wider, probably you will like to stay it outside because that you have an threat of damaging your car. Now, what is important? Next slide is park your car where you are reliable and you will park the car without any damage. So that is what is an ultimate objective of an Six Sigma, that you should be able to park your car very smoothly. Okay, so there are two approaches to this. Ek to you can increase your parking or reduce your car width, but increasing the parking is not in your hands because that is specified by a customer. So what is in your hand is reducing the variation in the process. So if you talk about Six Sigma, if you go on a Google and just put those words Six Sigma, what it will tell you, it is about reducing the variation. It is not only about reducing the variation. By reducing the variation, improving the capability of the process, that is what is an intent. So if you reduce the variation, your consistency will increase, and once your consistency will increase or improve, your capability of the process goes up. That is what is an intent of an Six Sigma, to improve the capability of the process on the scale of 0 to 6. So when I told you a story last time, I talked about reducing the variation to improve the capability of the process. So every time it is very important to focus on the improving the capability of the process. So with this, we end up a major phase. So let us have 10 minutes break and then we go move on to the next, which is analyze phase. So what we have done so far, that we started with an equation y is equal to fx1, 2, 3, 4 xn. And primarily in a define and measure phase, what our focus was on y. So we were talking about y. So y का हमने यूनिट सिटी क्यू हमने चार्टर बनाया. बाद में we established that my measurement system is right for y. Once we establish all that, we will go on the right side to find out what are my actual variation sources and what is their correlation is. So let us have 10 minutes break. So let us reassemble at 1850. Himanshu, that will be all right? Hello? Hello?
Yes, sir.
Yes, sir. Okay.
Yes.
Yes, sir. No issue. No issue.
We'll start
Yes,
at
sir. No
1850.
issues. Yes.
Yes. Hello. Am I audible?
Yes. Shall we start?
Hello. Am I audible?
Yes, yes, you are audible.
Sir, my screen is visible to you?
Yeah. Probably there is no movement. So if you click enter, it will hang. You'll have to go back and again reload. That is what generally happens when you are sharing a screen. If it is not in a movement for 10 minutes, it gets hang. So shall we start? Himanshu? Hello, can we start?
Yes, sir.
Okay, so go to next slide, please. So now we are moving to analyze phase, where again we are asking three questions. Identify variation source. What factors can make a difference? So what now we are talking about, which are the x's can make a difference for my y. Then screen potential excess to identify a root cause of the problem, and then discover the variable relationship, and uh, can I predict the output? So based on my input, can I say this will be my output? Means, will I be able to establish the relation between my x and y? That is most important question. Or optimize my x so that my y will come regularly or improve. So let us move the most important aspect of analyze phase is the basic QC tools. So we'll be covering basic QC tools, quality tools, to identify or screen the excess. So let us move next slide, please. So why these tools are called as basic tools? As next slide, please. Unless you use one of these tools, you can't go for an advanced tools. So you have to use at least one of the tools in these 7 QC tools. So these tools are quantitative as well as qualitative tools. Next slide, please.
Hello.
Hello.
Yes, sir.
Share the screen.
1 second, sir.
Yes.
Done, sir.
Okay. So next slide, please. So this is what we are able, we need to do as a deliverable of analyze phase. Identify sources of variation, determine root cause, uh, determine the relationship between y and x, and also identify a value or non-value added process steps if it is a transactional process or we are looking for a transactional process using a lean tools that we will look at next time. So next slide, please. So basically what we'll try to do, we will try to focus on basic 7 quality tools. There are various tools which are used in analyze phase. So these are basic 7 QC tools. Then there are new QC quality tools. Then YY analysis, correlation analysis, uh, binary logistic regression, contingency table, analysis of variance, failure mode effect analysis, value stream mapping, 7 waste, lean tools, and optimization using design of experiments. So what we will be covering as in part of an yellow belt is basic 7 quality tools. Then we'll also cover one of the important fault tree tool as in one of the new 7 QC tools. Then we'll look at an Y analysis. And most importantly, I will explain you correlation analysis during my next session at the start, because the correlation analysis and regression analysis is very important for you as a chemical engineer. If you go to the plant as a process engineer, you must understand that what is a correlation analysis and regression analysis. And I'm sure, means I always say, this is a bread and butter for any technical person or a CTS person. We generally use a term as a central technical cell. So if he is a CTS guy, the correlation analysis is a very important tool which he need to understand. I will explain you this tool, and then also we'll look at FMEA and then value stream mapping and 7 quality 7 waste or lean tools, etc. So primarily today what we look at basic 7 quality tools, then fault tree analysis and YY analysis and a box plot analysis. So let us move ahead with an basic quality tools. So basic quality tools, unless you use one of the basic quality tools, you can't move ahead in analysis. Next slide. So they support different situation by specific tools. So it depends on which tool to be used on the situation. So next slide. So these are the tools. This is the purpose of using a tool. So process mapping or charting, check sheet, stratification, Pareto analysis, histogram, brainstorming, control charts, scatter plots, or graphs. So what is their purpose? The purpose is identifying, prioritizing, analysis, and communicating also. And if you look at the bottom line, bottom punch line here, the sentence is said by Keiro Ishikawa, who is a quality guru in Japan. He says 95% of the problems get solved using these tools. So I'm repeating again, you don't have to go for an advanced tools. 95% of the problems get solved using these 7 QC tools. So it is very important for you to understand these 7 QC tools. These are, few of them are quantitative tools and few of them are qualitative tools. So what is the difference between a quantitative tools and qualitative tools? So quantitative tools, as I always say, it is on the numbers. So there are numbers available, and based on those numbers, you can understand or prioritize your access. That is what is the purpose of an tool are called as a quantitative tool. While few of the tools which are called as a qualitative tool, like process mapping, unless you go and number the defects at each step, it doesn't become an quantitative tool. It is only for identifying the steps and data collection plan. Or brainstorming and cause and effect is also one of the qualitative tool which is used in most of the projects, but doesn't talk about the numbers. It is only about generating the data. So I will explain you all these tools one by one. So let us move to the process map. I need not explain you process mapping again. It is what exactly we talked at the start of the session. In Six Sigma, generally, the process mapping comes immediately after you write down your charter because you need to understand the process. It also is one of the 7 quality tools. So when we are talking about the quality tools, only about the quality tools, generally we also have a process mapping as one of the tool and cover that during that period. So as we have done today itself, what is process mapping? I'm skipping those slides. So Himanshu, probably you can skip those slides, go fast. Go to the tool number 2. Yes. Yes. So this is what is a check sheet, or can also be called as a data collection plan. So next slide, please. What do you understand by a check sheet? If you are going out somewhere for a travel, probably you have a list of activities which are being done, and you tick that this is done, this is done. As you can see in this picture, somebody is having a bath, and he probably ticks a checklist whether he has cleaned the ears, neck, feet, etc. And just ticking that it is this is what is called as an use check sheet, checklist, or ensuring checklist. But in this case, this is not an ensuring checklist. What we are talking about a data collection check sheet. So how it works? So next slide, please. It is very simple. All the 7 QC tools, as there is a word basic, they are very basic, not a rocket science, very easy to understand. But what is important that you have to use these tools to collect the data. So what is the purpose of check sheet? Is simplification of data gathering, provides a preliminary summarization, and provides a basis for next level of statistical analysis. So next slide, please. So how does the check sheet works? So this is a simple example of a data collection sheet from a garment industry. So probably if you look on your screen, the shirts are being produced at one of the garment factory. And what he has done, he has mapped the defects on the shirts as a data collection check sheet. So he has got 3 types of defect. One is flaw, tear, and mark. So when he is actually drawing that defect at that spot, probably it generates some data. That is why it is called as a data collection check sheet. So one can identify there is a mark which is coming on a sleeve. This is of course a front view and a back view. So you can look at that. There are more number of marks or more number of mark type of defects only on the sleeves. So what probably you can go and look at, these tools are again a complementary tools to each other. So once you know this process, or you understand by checklist that I have a mark on a sleeve, probably you can go back to your process map where exactly you can go through or walk through the process. That is what is called a Gamba analysis in Japanese words, and understand why that mark is coming on the sleeve. That is also using a process map after a data collection check sheet. So once you look at that or you map the process, it may happen that you find out the reason for this mark, you eliminate that mark and improve the process. The next slide, please. The second example is about, again, a defect on a door paint. So any automotive industry where there are defects which are called as an bubble in paint. So you see bubble is appearing at particular spot. So one can go and analyze or map the process why bubble at particular spot. That is what is an intention of an check sheet, use of a check sheet or a data collection check sheet. Next slide, please. Very simple, but unless you do that, unless you have a data collection using check sheet, you are pinpointing a problem and you are just again looking at the process where this defect is generated. So the areas of application can be number of defects, location of defect, machine-wise breakdowns, causes of defects, etc. Go to the next slide. So the next tool is stratification. So basically the stratification is a method of grouping a data on a common points, or rather I will call it as in slicing a data by different ways. Now here, whole of an analytics today, which is very popular in IT, is based on a stratification tool. So if you go and say we are doing some analytics for retail, so what probably he is doing as an analytics, he is using a stratification tool to slice the data using his computer, simple Excel, and based on that, he will come to a conclusion. This is the area where there are more number of defects, or etc. etc. So next slide, please. So the stratification is slicing a data by who, department, individual, customer type, then what type of a complaint, defect, reason for incoming calls, then when, month, quarter, day of the week, time of the day, then where, region, city, specific location. These are just the guidelines. So probably it depends on your project and how you need to slice the data, and you can dice the data, and from that you can take out information that why is this happening. Is the tool is called as an stratification. So let us look at an example. Next slide, please. So the example is about an pizza late deliveries. So this is what is a bar graph of an pizza late deliveries in last month for any Pizza Hut or something like that. And the bar graph shows that how many less than 5, 5 to 7, 8 to 10, etc. And beyond promise time. This is bar graph for an late deliveries beyond promise time. Now, if you can use any type of stratification. So what I have done in this example is try to stratify data based on time. So next slide, please. So this is what is an data for whole of the day. So what I have done, I have sliced the data based on the time zone or time period. So what probably says the shop opens at 12 o'clock. So how many defects from 12 to 4? How many defects from 4 to 8? And how many late deliveries beyond 8 to midnight? So probably from this, you will able to understand that there are more number of late deliveries during night. And if it is late, how much is late? It is more than 17 minutes or 20 minutes late. So probably what you can do again, you can use a complementary tool of an process analysis. Go directly and analyze the process after 8 o'clock and look at whether how many people are there, are we running enough number of ovens, or there is a overcrowding of an orders after 8 o'clock, etc., etc. So you can find out those reasons. Look at an actual data using this stratification, look at an actual process, and then you can improve a process by identifying the reasons for them. So basically a first cut using a stratification data. Next slide, please. This is how you can use a tool called stratification. The fourth tool, which is called as a Pareto diagram. So this is also called as a Pareto analysis. And this particular tool is called a Pareto analysis because it was invented by Pareto, who was an economist, Italian economist, and his theory was based on an economic principle where he says that 80% of the wealth is with 20% of the people. Now look at, he died in 1923. Before that, he had this principle that 80% of the wealth is with 20% of the people, which is still valid. Even we have changed the century, but still this basic economic principle is valid, that 80% of the wealth is with 20% of the people. Next slide, please. Based on this economic principle, Joseph Juran converted that basic economic principle to a management principle he said 80% of the defects are due to 20% of the causes. So it is also called as an 80-20 rule or a Pareto diagram. So let us look at how a Pareto diagram is actually done. Next slide, please. So this is how a Pareto diagram looks like. The diagram has two scales, one on the right hand side and one is on the left hand side. So there are two scales which are used. One is for an frequency and another is for an cumulative percentage. So the punch word or punch use of this line is again identify vital few out of trivial many. So whole purpose is that you have an potential reasons. From that potential reasons you are screening the vital reasons. So from many reasons you are coming narrowing down on few reasons and identifying also what is the impact of that particular reason. So next slide, please. I will explain you how to draw a Pareto diagram. So just look at an example. These are the assembly line defects. So what are the category of the defects? A, B, C, D, E. This is the description of the defect. This is a quantity of defects generated out of 150. Okay. So I have a category of defects A to H. Then the description is written for that A to H. And I have also a number of defects for that particular category out of 150. And I have also a percentage, that is how the 47 is 70 divided by 150 is 47. So if I sum these all percentage, it comes to 100. So when you are drawing a Pareto, next slide please, what you are trying, you put all these in a descending order. Either by quantity or percentage. You can also draw a quantity or a percentage, doesn't make a difference. I have drawn a percentage. I have gone through a percentage wise. So percentage is used to have a bar graph. Otherwise, you can have a quantities also for a bar graph. So once you have put them in a descending order, the third column is about the cumulative percentage. What is this cumulative percentage say? The defect A contributes 47%. The defect A and D contributes 62%. That is 47 plus 15, 62. 62 plus 10, 72. 72 plus 8, 80, like that. Okay, it is 87. There is a mistake here. So 80 plus 80, 87. Like that, it goes to 100. Now, if you want to draw a graph now, this is an mixed graph with two scales. So you draw a bar graph based on the left hand side scale. So it is percentage. Okay. So 47, 15, 10, like this. And there is a line graph, bar and line graph. This is called as a bar and line graph also. Cumulative percentage, where you start with an 47%. You can put this dot here, here, anywhere. Doesn't make an issue. So 47, 62, 72, 80 goes up to 100. Next slide, please. So what does this says? If you draw a line from 80 and come down here, it says 80% of the defects are due to these four reasons. So, the idea is here is to work smart and identify which are critical reasons. So even if you work on one of the reason which is contributing you 47%, if you improve A or eliminate A, you will get an improvement to the tune of 50% in the process. So that is what is said, where you have to focus, you are prioritizing the thing. It is very important to understand that A, D, E, G, B is your vital excess to work on. That is what is important. Identifying vital few out of trivial many, or identifying critical excess from potential excess. So this is how it can be used. The graph is very simple, but this is generally used in all types of defects, financial analysis, how is money spent, etc., etc. Okay, next slide. So reason, causes of defect, reason of delays, etc. Next slide. The next tool is very important, which is called as a brainstorming and cause and effect diagram. So what is brainstorming is exactly, the brainstorming exactly is in generating idea, means potential causes. Now, if you, so there is a systematic way also of identifying potential causes, it is your process map. But even now suppose you, as you understand, these are the complementary tools. So you understand that there is a bubble on a car door at particular place. So you can assemble a team and do a brainstorming why you are getting bubble at particular spot. You map the process, but apart from that also you can generate many ideas or potential causes for improvement. Now this is a very important qualitative tool. This is not a quantitative tool. But now what is important in the project generally, there is one aspect which is analysis. But what is very important for an improvement of implementation of the project is consensus building for a solution. So this is a very good soft skill tool to build a consensus among the team to develop a solution. So what generally is being done, all the members or all department representatives from all departments are involved in this process, so that everybody who is involved in the brainstorming feels that it is my solution, and everybody feels that yes, as a part of a brainstorming, we have come out of this solution, and there is a buy-in to implement that solution. That is what is a very important aspect of a brainstorming and cause and effect diagram. So the challenge when you are doing any implement you don't have an organization background, but generally when you will go to an organization, it may happen that one is an data driven process. If the culture of the organization is of that type, everybody is believing in data and respecting in data, they will implement the solution. But generally, it doesn't happen in the organization. So what we need to have is a consensus building for implementing a solution. So how we can build a consensus by for implementing a solution is involving them in a brainstorming. And once they are involved in brainstorming, they feel that I am also part of a solution, and it has come out of our discussion or rather brainstorming. So he will definitely support the implementation of the solution. So generally, I always say, what is effectiveness? Effectiveness of an individual is Q into A. Slightly away from Six Sigma, but will be useful for you in your life. So what is effectiveness? Effectiveness is Q into A. So what is Q? Q is a quality of an solution, or you can say quality. And into A is the acceptance of the solution. So to be very, if you come out with a very dasu idea and you rate that on Q on 0 to 10 scale, probably if you say my idea is very dasu, it is 10 out of 10 on quality. Fantastic idea I have. But what is the acceptance of that idea? If it is only 3 on 1 to 10 scale, then you reach out as an 30%. Your idea is so 7, but your acceptance is 6 or 7 out of 10, then you reach out to a scale effectiveness of 49, which is more than 30. So what is important in this is what is the acceptance of the idea. And to have that acceptance of the idea, brainstorming is the tool which need to be used when you are improving any process or conducting any process improvement study. So let us move ahead. The brainstorming, next slide please. So what are the basic rules of a brainstorming? Don't jump to a conclusion. So no idea is treated as a stupid idea. The idea is to generate quantity. So 100 potential excess. So you can discard the excess anytime based on the data or evidences, but you cannot add X. And this is the time you can add X. I will share with my experience. I started one project with 168 X's. Of course, it was in process parameters, various process parameters. And as I went ahead using a correlation analysis, I arrived only on a 4 X's which are having a relationship with my Y. Okay, so the idea here is to generate idea so that you don't miss out anything. Uh, Now, when we are generating those ideas, the atmosphere has to be climate has to be very safe. People should be imagine freely, uh, tell their ideas very freely in front of the senior bosses, etc., etc. And there is one more important thing which is stress during brainstorming is building on ideas. So it may happen that somebody X talks about some idea, but he doesn't have a solution on that. So some Y can build an idea on what X says and come out with a solution. Like that, you have to build on ideas as a group. That is what is expected in the brainstorming. Next slide, please. Brainstorming is a basic tool which is used for any process improvement. So different ways of conducting brainstorming, that is round robin method, means the 10 people are assembled and each member in rotation will be asked to speak out only one idea. It is not like that the production manager or head of the department or the boss will speak on the ideas and then abhi mera ho gaya, aap bolo. It is not like that. Everybody will get a chance to speak one idea, and if somebody doesn't have idea, it will get passed to the next one, and we'll record the ideas till everybody's ideas gets exhausted. This is what is called as a round robin method. There is also an idea which is called as a widest idea brainstorming or reverse thinking. Means we always think in different direction. So what can be the worstest thing or what can be reverse thinking, and then find out what are the different solutions on that. This type of a. Then there's a third type which is called as an 6-3-5 brainstorming. Generally, what is required when we are doing a brainstorming, it is required that team is homogeneous. So I think you understand what is mean by an homogeneous. So all people are friendly and very interactive, and everybody's idea will be welcome. They will respect the ideas. The culture of the organization or team should be such that if suppose you have a people from a cross-functional team, then somebody from sales, somebody from marketing, somebody from purchase, etc. The people don't know much to each other. The group is not homogeneous. Then generally this 6-3-5 brainstorming is being done. So what is this 6-3-5 brainstorming is? Because you are not spelling out any idea or speaking any idea, you are writing idea. So what is this? The 6 persons assembled together, 3 ideas are written by each one, and then it moves to a next person, and next person will read on that paper 3 earlier ideas and either build on that idea or will write down a fresh idea. Like that, each and every people will move to all of the persons and they will write down the ideas which are not written on that paper. So many of the times this becomes very effective. Means it depends. If the group is not heterogeneous, homogeneous, then probably if the people are not open up or has a fear that people will laugh at them, how can I speak in front of these people? This technique is used. So next slide, please. So what is the effective way of brainstorming? Give everyone chance, not criticize idea. Ideas can be expanded, etc., etc. Next, free expression of the language. He should be comfortable to speak out in any of the language that what he feels. Next slide. Once these ideas are generated, then they are categorized. Next slide, please. Next slide. Based on the cause and effect. So there is always effect and cause relationship. So all of the Six Sigma or improvement methodology works on the effect and cause relationships. As I said, y is equal to x1, x2, x3. So y is the effect and x, x2, x3, x are the causes. So it is very important to understand what is the effect and what is the cause. So the rooster crows when the sun rises, what is the effect and what is the cause? So putting that into cause and effect is also called as an fishbone diagram. It is also called as an Ishikawa diagram because Ishikawa invented that. A Japanese scientist Ishikawa invented that. It is also called as an cause and effect diagram, fishbone diagram, or Ishikawa diagram. Next slide, please. So what we basically do, once we get all those reasons out of brainstorming, we categorize them in different buckets. So what can be the buckets? If we are talking about the transactional processes, it is called as a 6 P's. Okay, and if we call it as typical manufacturing processes, it is called as an 5M 1P. So earlier it used to be a 6M, now that is 5M 1P. So it is person, machine, method, mother nature, material, and measurement. So it is again not hard and fast that you categorize them using 5M 1P only. You can also categorize based on your category or your problem or your area of problem. So, but this is just a guideline that how you categorize those all brainstorming ideas into using cause and effect for a better understanding. Next slide, please. Here we can also go for a second level of an cause. Now, if you look at this, a simple problem which is called as an poor housekeeping. So poor housekeeping is basically you go to any you say main in the category main poor habits. So this is why poor housekeeping. First, why is poor habits? Why poor habits? The culture. Why culture? There is a lack of training. Like that. So you go from main first why to why, next level why, next level why, next level why. You can also call it as an y1, y2, or y11, y12, y113, etc. So means you can give that number to your convenience and go. The idea is you are stepping from an first level to a next level to the next level and to the next level. That is what is the idea. Keep on asking why. It is also called as an why analysis as a separate tool. We'll consider that. And the idea is to go to the root cause. Next slide, please. So this is basically man method. Now here, conflicts at workplace. You can do it for any problem. So what are self-related problems? What are boss-related problems? What are subordinate-related problems? What is peer group-related problems? And then you go and analyze, you quantify them based on your observation. And then with those observations, you can say, means this is a qualitative tool at this time. You generate or collect the data on this and make it as a quantitative to make an informative vital tool. What are the vital reasons out of these travel many reasons? Next slide, please. Okay, the next is histogram. So what is histogram is basically a presentation of variation in data. So whole of the statistics start with the distribution of the data. So it is a simple bar graph which is called as an histograph. Second, next slide. So what does a histograph tells us? Basically, it tells us three things. Where is the center of the process? That is mean. Where is the width? How much is the width? Means spread of the process, and how is the overall shape? So what is the overall shape? Whether it is a normal, whether it is non-normal, skewed right, skewed left, etc. Whether it is off-centered. so that we can take required actions for the process to bring it in the center, or if it is skewed, we can make it a normal, etc. So next slide, please. How to make a histogram? What are the examples of the histogram? Height of the adult male in the city, and then 15-year-old boy in the town. Now, where is this histogram is used? Now, very importantly, any garment industry, any chappal or shoes making industry, because they don't produce 7, 42, 44, 46. So how much to produce 42, how much to produce 44, how much to produce 46? It all comes from an histogram data. And if you want to compare the marks of the students, then the score of Virat Kohli in IPL 16-20, or rather if you want to compare the performance of Rohit Sharma and Virat Kohli, you can probably have the both histograms for both, so that you can understand whose average is this, who has a better variation, or etc. That is comparing the two data sets is a use of an histogram. Next slide, please. So how do we draw? Typically the bell shape histogram is the best histogram, which has a peak in the middle and goes smoother on both the sides. This is what is called as a bell shaped histogram, and which is also called as a normality in the process. So if my process is having a bell shaped data, that means I say my data is normal, like that. So next slide, please. So how do I have an drawing a histogram? So let us look at how to draw a histogram. It is very simple. You have scores of 12 students in a science. Maximum marks are 100. So if you have the scores, the next step is to find out minimum and maximum. Next slide. So lowest value and highest value. Based on that lowest value and highest value, you can have an appropriate intervals. Next slide. And based on that interval width and boundary interval, you can have a frequency distribution in those intervals to draw a histogram, which is a simple bar graph. So next slide. So what is lowest is 25, highest is 92. So my range is 67. Next slide. So based on that 67, I can have a number of intervals. Next slide. There are formulas also to calculate the number of intervals. While there is a general guideline also, if you have a number of observations under 50, you can have 5 to 7 intervals, 6 to 10 intervals like this, or you can use this formula for calculating the intervals also, which is method 2 and method 3. So why we need to have an intervals? Basically, if we have only 2 intervals, suppose in the same example of marks, if I say one interval is below 35 and above 35. So what will that give me? That give me how many people pass, how many people fail. So that becomes in my discrete data. So if I have more number of intervals, probably I get to know more about the data, about the variation in the process, where is the center, how it is distributed, etc., etc. So it is better to have more number of intervals, but even not too many numbers of intervals. So there is a theory which is stated to have an optimum number of intervals based on these formulas. Next. Next, once you have an intervals, you can find out interval width. Next. So once you have an interval width, the frequency is on a Y scale, while on the X scale, you have intervals. Next. So you have now frequencies available, and based on that, you can draw a bar chart. Now, what is important to understand here in this, now if you look at mean and median, they are different. Now, if your data is normal, means perfectly bell-shaped, your mean and median will be same. But if your data is not normal, this is a case of an data where it is not normal. So if your data is not normal, generally what we do, we consider mean as an normal representation of our processes. But that is not correct. If your data is not normal, generally in the median has to be considered as an midpoint, because it is a midpoint of your process or presentation of your processes. Now, when you go for your placements, probably the HR people will come to you and they will tell you, or you must have gone through the Google, etc. also to understand. The HR people will always tell you the median salary for the people. They don't talk about the mean salary. So why is there a difference between mean and median? So when you are talking about a mean, it talks about each and every value in your data set. So extreme values also have an influence on the mean. Means somebody gets an highest package and somebody gets an lowest package will also impact the mean. If both of the events happen simultaneously, probably it will go to an average. But there is a highest package only available in this, then probably you will have a picture that the mean is high. But the middle figure, median, will not be that high. Because median is not influenced by an extreme values in the data set. So when the HR people will come to you, they will always talk about the median salary given to the people, employees. Okay, so there is a difference between mean and median. If your data is normal, then mean and median are same. If your data is not normal, then median is the right representation of your data. Next slide, please. So you will understand that only when you will draw an histogram. Like if you look at this slide, there is a graph which is shown on the right bottom. You have two highest values there, which we call it as an outlier also. And these two values will always, if it is a higher the better function, it will always influence the mean, but it will not influence the median. So it is very important to understand the overall shape of an shape of the data set to conclude that whether it is normal or not normal. So these are the different types of histograms we can see. The idea or the purpose is to understand whether the distribution is skewed distribution or there are any outliers in this. If there are outliers, I try to find out why those outliers, and the reasons for that why comes as my potential causes, and I get them as potential causes and go for a further analysis. That is what is the idea. Many of the times you can also see a double pick histograms also. Means on the left top you see a double pick histograms. So this is a representation when you are talking about the performance or combining the performance of the two machines. So I have two cars. I am talking about the average of A and average of B. And then as an overall process, I am talking average of two together. So probably it will happen that one car has average this and one car has an average of this. And that is why it is showing me as a double pick histogram. Next slide, please. So the histogram is basically to find out, to understand how my data is, and then take probably the next action. Now the 7 tool is about the graphs. So I will not explain you the graphs because you are well convinced about the graphs. So next slide, please. It is a XY graph. This is a bar type of a graph. I will explain you only few graphs. This is a pillar graph, like a bar graph. Next. This is a bar graph, vertical, horizontal. Then this is also very, you must be familiar with this. Next. This is a belt type of a graph. means you have done a stratification in this graph. So what is my total and what is the breakup of that total? So that is what has been done. So this is QCFI, is Quality Circle Forum of India, conducted few training programs in 88, 89 onwards. So 88, 89 to 2004, slightly older data, says ki how was the breakup of my programs was. So if you look at that red line, which was very normal, now has increased. So this is how it can be done. 1 minute, battery low. हो गया. So basically it is a stratification of the data. And based on that, you can conclude or you can take a judgment that what has increased, what has reduced, etc. This is what is called as a Bell type of a graph. Next. So this is a pie chart. We all are conversant with this. Next. So this is a compound graph. What we looked at Pareto was a one type of a compound graph. Next. So this is a radar graph. So what you can do using a radar graph, you must have not seen this. So what you can do in this is earlier slide, Himanshu, please. Earlier. पीछे और एक पीछे आगे जा रहे हो आप. So ये क्या है? This is a round type of a scale where you have suppose you have 8 topics and you want to understand the score score before training and score after training. So you have 8 topics and you conducted a test before training and you conducted a training, and how much is the score after that. So this can be put on the radar chart. So what is the radar chart? You have basically 0 to 100 because your maximum score is 100. If your maximum score is 50, you can scale it like that. Next slide, please. So what you are doing is you have drawn first what is before training scores. So check sheet, probably the score is 50 or something like that. Or control charts, again the score is 42 or something like that. And the next slide, please. So what is the change? So for each and every topic, what was my earlier score and what is my after score? So where there is a more delta, you can say it has improved a lot. While if you look at an cause and effect diagram topic, there is not much improvement in this. So probably you can understand from this graph that we need to do something differently for a chapter called cause and effect diagram, etc. So that is what is called as a radar chart, where you draw before and after. And from that delta, you understand where the improvement has actually happened and improvement has not happened. Next. So next is an scatter plot, which is X versus Y graph. And from that X versus Y graph, actually, if X increases, Y increases. That is what we call as a positive relationship. If X decreases, X increases, Y decreases, we call it as a negative relationship. And that is what we can understand visually using these graphs, which is called as an scattered plots. Now, when we will look at actually what is a correlation, so the Six Sigma is all about the numbers. So we can't go with these numbers or visualize subjective analysis. So we'll try to convert this into a numbers called positive relationship or negative relationship by way of calculating a coefficient which is called as a coefficient of correlation, and which is a very important tool. I will explain you during my next session. So once you understand that using this scatter plot, yes, there is some relationship between my x and y. I go and quantify that relationship, which is called as an correlation of coefficient or regression. So next slide, please. So common examples of relationship: cutting speed, tool life, moisture content, thread elongation, breakdowns, equipment age, temperature, lipstick hardness, striking pressure, electrical current, etc., etc. Temperature and percentage foam in soft drinks, etc. Okay. Next slide, please. So with this, we complete 7 QC tools. Now we move to the new QC tools. These are the new QC tools. These are basically not quality tools. These are called as a management tools. But what is most important tool which is commonly used in root cause analysis is an fault tree method. So I will explain you fault tree method, which is similar to YYY analysis, etc. So let us move to a fault tree method. Next slide, please. So we keep on asking question why. So it is built on an effect and cause relationship. So effect is at the top. We come to a next level, treat that as an effect and identify what are the causes. So next slide, please. Okay. So simple. Car stopped at signal, could not start. So this can be either or events also. Means both of them has happened or only one of them has happened. So why the car can stop? There is no petrol. So what is this? No petrol is a potential reason. And problem with the engine. So it can be a both reasons or only one reason. So here it is only one reason, which is problem with the engine. Based on, generally this is done in analysis of events, means accident analysis or generally post-mortem type of events when actually something has happened and you are trying to find out the root cause for that. So fault tree method is generally used for analysis of the accidents, etc. So or the events. So car stopped at signal. So I have two reasons. I ruled out one, then go for this. So what is effect here? The effect here is car stop. Probably these are two causes. I eliminate one cause. I say this as an effect and go for another cause. Like that, I drilled it down where I actually change the process or a system. So I keep on asking why till the process is in my control or I can influence the process. Till that time, you keep on asking why, and then no combustion in the cylinder. So air fuel mixture problem, etc. Air supply inadequate, choke setup incorrectly. Why choke setup was incorrectly? No SOP for checking or poor workmanship. Now, poor work, either you can work on this as in poor workmanship or set up an SOP, or you can even go down to identify why poor workmanship, where you will reach out to an HR for identifying a person for that job role, etc., etc., can also be done. If you want to go to and identify a root cause like that. So, but keep asking why till the process is in your control or you can influence the process. Now, in this case, workmanship, if you are able to, as an authority leader, you are able to influence the HR to recruit a particular person for this job, then you have addressed another root cause of this, another level of why, and that is really the root cause for the problem. So you need not to work on this, and you have identified the next level of why. So this is how you have to go, keep asking why. Next slide, please. So that is what is also called as an why analysis. So just a story from an Ramayana. Keep it in a lighter mode. It is not that you took it seriously, but there was a war between Ram and Ravan. Ravan was killed. Why? Because Ravan kidnapped Sita. Why? The Ram and Sita were staying in Vanvasa. Why they were staying in Vanvasa? Because Kaikeyi, the stepmother of Ram, ordered so. So why Kaikeyi ordered so? Because Kaikeyi had an Vardhan from an King Dashratha. So why Kaikeyi had an Vardhan from King Dashratha? Because the Kaikeyi saved King Dashratha by inserting her finger while wheel of his Rath was collapsing during the war. Dashratha was fighting a war and wheel of his Ratha was collapsing. Kaikeyi saw that and put her finger instead of that bolt, and with that Dashratha got impressed and said, "You ask me anything," and then she asked Vanvasa for Ram. So reliability, poor maintenance practices. So what is the process? Probably it is important to understand there was no process or system in place for maintenance of the collapsing wheel, or that is what is the root cause of the problem. So if you keep on asking why, and then you address a process or issue, reach to process and issue system, where you change a process or a system to improve your why. That is what is an objective, and Six Sigma can be done using a why analysis. So this is how you can use a why analysis. Keep asking why. So next slide, please. I think Himanshu, we will stop here today because next is on box plot. So we'll start with a box plot during the next session. So any questions so far? Any doubts that you have not understood?
Anybody have any doubts? Anybody have any doubts?
So anything you have not understood, needs more clarity?